Hello and welcome to my video. This is Mark Moody. I'm going to demonstrate very quickly the entire universe in just a couple of minutes and no math. So here we are. This is a 10,000 digit calculator. It's just like any other calculator, but instead of the answer being 1232 digits, we get 10,000 digits. This has led to some incredible discoveries. Scientists didn't have this before. Now, you take the Moody pilot wave. This is the frequency of the Moody pilot wave: 1, 2, 3, 4, 5, 6, 7, 8, 9, and then reversed 9, 8, 7, 6, 5, 4, 3, 2, 1. In this case, I've doubled it because I want the answer to be a little bit more spread out so that I can show the results better. But same thing if you do it without doubling it. If you do it without doubling it, you divide by 1. If you do it when you double, divide by 11. Now, dividing by 1 on a frequency, because this isn't a number, it's a frequency. If it's a number, it doesn't tell us very much at all. It's just a stupid number. We use it for a few things and we think we're smart. No, it's a frequency. Every one of these numbers has an individual frequency, and they all combine together to combine a group frequency, which contains incredible amounts of information as a frequency and not a number. As a frequency, we can divide it by 11 or by 1, and we know that anytime you divide a frequency by 1, you get the wavelength. We also get a ton of other information that we didn't know about. Um, so I just divide that by 1, and we get this huge 10,000 digit number, but it's not a number, they're frequencies. So they contain huge amounts of information. If you divide each one of these by 1 again, you're going to get a whole other huge amount of information. Always 999 digits, exactly, because that's harmonic. Now, the first number we have is 9801. Okay, that's Newton's gravitational constant. It's also, as you'll see, it's Moody's pilot wave main frequency and the size of our universe. Now, divided in 1/2 is 49005, so that's 1/2. This 88209, the speed of light squared, because 279 squared is 49005, is 1/3. And this divided by this is 1/4. This divided by this is 1/5, 1/6, 1/7, all the way down in perfect harmonic sequence. These numbers never fall out of that sequence. Also across, this is 1/2 of this, 2/3 of this, 3/4 of this. So all the way across, it's harmonic series perfectly. So here we have a perfect matrix whose determinant is 0. We don't have to run this to know that it's going to be 0. So this has infinite solutions. Okay. Now this speed of light being 1/3 of 9801, because that's 1/2, and then 88209 divided by that is 1/3, and this divided by that is 1/4. So we can see the universe is 3 times bigger than the speed of light. So the universe is the exact size we would expect to find it. Now, there's also a lot of other things here. For one, this is called analytic continuation. Okay, it's a requirement of the Riemann Zeta function. Um, that you be able, that's what the Riemann Zeta function actually is, no matter what they've tried to switch it around to. It is an analytic continuation. That's what it's supposed to be. Um, this is an analytic continuation, but the difference is why it works and the others don't is because this is in perfect harmonic series and it's entangled. Now, this makes it able to create an immense amount of data, enough data to hold the entire universe's information in one simple calculation, because it's in harmonics and entangled. So no other solution to the Riemann Zeta is going to work. It has to be an entangled harmonic series to make this kind of data. Now, the other thing we see, like the Riemann Zeta, is the trivial zeros. Here they are. Those are trivial zeros. And they do pass all the way. They keep getting smaller and smaller and smaller and smaller and smaller and smaller, trying to get down to a point of 1. Now, they also, if you'll notice, are way less than 1, but they're not less than 0. These lie on the line between the point 0 and 1. And look at this, right down the center, exactly as Riemann predicts, are the prime numbers, falling right down the center. The prime numbers, yeah. This actually creates the prime numbers: 1, 5, 13, 17, 19, 23, 29, 37, 41, 49, 53, 60, in perfect order. Okay, that's not just picking numbers out around. There are not very many numbers on that page. So it's not just lucky that they happen to be there. It happened to fall right down the center line as Riemann conjecture predicts. Okay, so we've got the trivial zeros. We've got the analytic conversion going down. We've got the harmonics that Riemann requires in his 1/2, 1/2, 1/3, 1/4. So we've got everything that Riemann needs in his conjecture, and there's no way anything else in the world is ever going to do this besides this. Now, you could use different waves in it, but you still have to go by 9. You still have to have it in perfect harmonic and entanglement, or it's not going to work. Now, I mean by 9 because this 9, 8 plus 0 plus 1 is 18. 1 plus 8 is 9. 4 plus 9 plus 5 is 18. So horizontally, these all equal 9. Every single number on the page. And this 9 is important because that's what gives it the harmonics. And that's what I used in the Zeta function to prove. And the Zeta function that I did it with is actually this. It all equals this. You can just divide by 1 instead of doing all that Zeta, and you get the same exact results as doing the whole Zeta function. So now this is what I say it is, which I say it's a light beam. Okay, a light beam created the universe, and this is a light beam. Now, and this is exactly what you get when it explodes. Boom, all this code. That's what you get. So when we de-evolve it and take it back from the start, we should get an electron. How do you get that from code, though? How could that happen? Watch. Ta-da! And there's the electrons. Notice everything else on the page has not changed. It all still looks perfect. But the code, being what it is, the harmonic series pattern has definitely evolved. And you can see it evolving. Very interesting and amazing patterns. And then, boom, here it is, the code. So what happens is, this is where it starts, comes up here as a wave, explodes in the decoherence, in the collapse. Now, if you take all this information that came out during the explosion, just copy it all, and paste it right in there and divide it by 11, you're going to get this. You're going to get the frequency. Sorry, you're going to get the frequency. So, because this divided by 11 gives you all that, you divide that by 11 and you get all this. So that means all this information is in this code, is in this frequency. And each one of those frequencies you can do the same thing to, and literally they'll never lose the harmonic sequence. They'll never lose the entanglement. It'll carry through no matter which one of these numbers you use. So this is the analytic continuance in a amazing matter, and you can see it's what Riemann was after, because by being able to do this, you've got the solution to the universe in your hands, because these numbers you'll see, speed of light, and this number is the size of our universe, as you'll see from my other papers and other confirming scientists. These are all very real numbers, and this whole system is very real. Um, so in regards to the Riemann conjecture, yeah, it's the Riemann conjecture, obviously. I mean, it's got what freaks me out is that Riemann was so accurately able to provide an explanation of this. I mean, it's incredible how he knew the prime numbers would go right down the center line, how he knew about the trivial zeros all passing in a point less than 1. He knew about the harmonics, but he never could figure out the pattern, which is the Moody pilot wave. So how he knew about this and was able to describe it so perfectly freaks me out. That's something going on in the universe that we don't know about there, because um, it seems simple now that I can explain all to you and I've got it all figured out. You just divide by 1. But it wasn't simple. It took years and years and years to get it to that point. So how he could have done that, I don't know. Um, but yes, this is the Riemann conjecture solution. He is correct. The zeta function will provide, but only under the specific circumstances of a harmonic series wave that is entangled. That's the only time that's going to happen. So there you have it. And there's the universe in a nutshell. Have a good day. Read my papers. You'll get all the information about everything up on academia. And have a good day.